Yes, now. So, I guess now Opera has come and we can start. And Opera asked me whether I could introduce Oystein because I'm the one who has known him the longest. And he came to me as a mathematics student and asked whether I had some advice to give him because he wanted to go into philosophy. And I was very, very happy to have very good students coming from other fields and decided to go into philosophy. And in the case of Oystein, it was a really quite exceptional student who came, because in the 200-year history of the University of Oslo, nobody has got a better total grade than Oystein. I think he's matched by one person, two of them who have this top grade. The other one was Atle Selberg, who went straight to the Institute for Advanced Study in Princeton for mathematics. And Oystein was looked upon as, by the mathematicians in Oslo as the big coming star of Norwegian mathematics. And then he goes away from them and goes to philosophy instead. So then, you know, it's always tempting when you have a good student coming to you and says that he wants to study your field to offer his advisor. But that would be very immoral because we don't really have a proper broad program in Oslo for the PhD. So I told him that he should go abroad, and not only that, but I told him he should go to Charles. Charles would be the best person he could work with, given his interest in the philosophy of mathematics. And he was very obedient and I think we are both very, very happy with the result. I'm especially happy because he decided after all this to come back to Norway. And I'm very happy that the department is in very good hands now with Oystein. But in any case, what he'll now talk about...
Some PhD students even get to stay.
Yeah, they stay, but we still send people abroad because we still don't have that broad background that you get at a good American university.
But Charles has retired, so what's the point?
Well, of course, it might be a problem now. Where should we send them? That's right. Yeah. Well, we'll see when the next person comes. We'll have to look at the departments all over. But in any case, we'll now hear Oystein, and he will talk about modality in mathematics.
All right. I'm going to try to speak without the microphone and just be loud, if that's all right. My sense is that the sound quality is not a whole lot better with the microphone than just using the voice activate. It's a great pleasure to be here at this conference in honor of Charles and his work. And as Dagfinn said in his very kind of introductory remarks, I did go to Harvard primarily in order to study with Charles and have learned a lot from him over the years. And he really has been a role model in terms of the precision with which he works, the demands of clarity and rigor. So there's a lot to live up to. So many of us feel, most of us feel that way. So my topic at any rate is modality in mathematics, and this is a topic to which Charles has contributed quite a lot. There's a handout version of my slides, by the way, going around. There should be enough copies for everyone. It's not that.
Does everyone have one? Everyone who doesn't?
It's all on the slides anyway. So let me start then by mentioning one place in Charles's work where modality does come up. So this is when explicating the iterative conception of a set, which is ordinarily done by talking about how sets are formed in a series of stages in some sort of quasi-temporal way. And Charles then writes that we need to replace the language of time and activity that you find in this ordinary, at least to a first approximation, characterization of the iterative conception. Replace that by the bloodless language of potentiality and actuality. Right? So modal notions having a job to do in the explication of the iterative conception. So my agenda is to give some examples of the use of modality in mathematics, focusing on Charles's work, but going a bit beyond. And then look at arguments to the effect that this modality can't be metaphysical modality, as we have it from Kripke and Lewis and others, which then raises the question, what is this modality that's being used in mathematics? And then how does this modality interact with other modalities, like metaphysical modality, if you believe in that, or natural modality, or just about any other modality would give rise to a version of that third question. So let's start for real then by having a closer look at some of what Charles says about the metaphysics of sets and how modal notions come up here in a very substantive way. So this is a passage from his very influential article on the iterative conception of set. So a multiplicity of objects that exist together can constitute a set, but it's not necessary that they do. Given the elements of a set, it's not necessary that the set exists together with it. However, the converse does so, and is expressed by the principle that the existence of a set implies that of all of its elements. Right? So the idea is that when you have the elements of a would-be set, then it's possible for that set to exist. But when you have the set, then the elements must exist. So here's a modal way of cashing out at least a great deal of what is said in that passage. So I'm using the resources of plural logic, as we have it from Rules and others. So double variables for pluralities, or for talking about many things simultaneously. So potential existence, PE, necessarily whenever you have some things, it's possible for there to be a set of just those things. Right? That's clearly part of what's being said here. And then when something is an element of a set, necessarily if the set exists, then so does that element. And of course any other element for that matter. Right? So I think that's a pretty good way of cashing out in a formal way what's asserted in this passage. Now, I know from experience that one of the reactions you tend to get at this point is that, look, how can this be? This means that there isn't a fixed domain of pure mathematical objects. So which pure mathematical objects there are varies, so to speak, from world to world. How can that be? Doesn't that conflict with the idea that pure mathematical objects exist of metaphysical necessity? And that's a standard response that one gets when you say things like what Charles says in that passage. So here's an attempt to articulate that kind of suspicion or concern in a somewhat more serious way. So there's a threat of modal collapse at this point. And the argument uses two premises. So premise number one says that pure mathematical objects exist necessarily, if at all. So necessarily for anything, if it's a pure mathematical object, then necessarily it exists. Right? And the second assumption is simply the Browerian action of modal logic. So whatever is possibly necessary obtains. And then having these two principles, both of which are held widely for metaphysical modality, then this collapse seems to go through. And it's very, very simple. So look at potential existence. Again, as I formulated it on the previous slide. This asserts that it's possible for an object to exist of a certain sort. Now, if that kind of object exists, it will exist by necessity. So you can go then to possibly it necessarily exists. But then by the Browerian action, whatever is possibly necessary obtains. Right? So you could go from 2 to 3. And this then is fatal. Since now you're saying that necessarily for all pluralities, or whenever there are some things, there actually is a set of those things. So consider now all the non-self-membered sets, for instance. They would actually give rise to a set according to 3, so you get a version of Russell's paradox. Okay, so it's really important for this kind of position that Charles is advocating, as on the previous slide, that you not have this kind of collapse. Because then it would be paradoxical. So it's absolutely essential that the existence here of the set be potential relative to the existence of the members. Not that it should be the actual, it has in 3. So that's bad. So something will have to be said to block that kind of argument. But before I go on to talk about ways of responding to that argument, and of course there are various ways of responding. Let me mention some other places where modality comes up in mathematics. So the oldest case is, of course, Aristotle on potential infinity. So according to Aristotle, which is my favorite example of it from Aristotle, the infinite divisibility of a stick. So consider a certain stick S, and let P now stand for the relation of being a proper particle. So then force says that necessarily, given any proper part of that stick, you could find a proper part of that integer. So in other words, it's possible to keep dividing the stick to find ever smaller proper parts of that stick. But what Aristotle denies then is that you can complete infinitely many of these divisions of the stick. So he denies that it's possible for it to be the case that for any proper part of the stick, there in fact is a proper part of that integer. Right? Since that would require there to be actually be infinitely many parts of that stick. And Aristotle, of course, thought that completed or actual infinities were incoherent. So for Aristotle, it's absolutely essential that 4 should hold, and that we need to make that negative claim in 5. He says something very analogous concerning the potential infinity of the natural numbers. So necessarily for any natural number, possibly there is a successor. So you could always find a successor or generate a successor, say by instantiating that larger number by dividing the stick one more time. What's not possible is to complete the formation of infinitely many natural numbers. So you have that negative claim in 7 that it's not possible for it to be the case that for any natural number there in fact is a successor of that number. So you see that's structurally very, very analogous to the situation we had in set theory, where you say that necessarily for any things possibly there is a set, but you deny that that process of set formation can be completed. So Aristotle too, in what he says about the potential infinity of the natural numbers, is vulnerable to the kind of modal collapse output that I looked at. So he too also responds to that. Now before I look at responses, let me give you yet a third example of modality in mathematics. And this is from using modal resources to actually develop in a somewhat more axiomatic way the iterative conception of set. And this is drawing on Charles's work, but doing some of the steps in my own way, as developed in work I've been pursuing. So we start then with talking about the generation or formation of sets. And this needn't be sets exclusively, by the way. It could be generation of any kind of mathematical object. So Condor famously talks about the two principles of generation of number, so that too could be done in this framework that I'll develop now. So I'll start by talking about possible worlds representing the stages of this process of generation. And then I'll try to find a modal logic to represent that process. And there's an accessibility relation then relating these worlds or stages in a very natural way. Namely, one stage is accessible from another one if you could get from the latter to the former by generating more objects. So this suggests that the accessibility relation should at the very least be a partial order. So it should be reflexive, transitive, and asymmetric. Then there are questions about what you should do when there's a choice what to generate. So assume you have a bunch of objects and you could generate, say you have generated all the natural numbers. And you could then generate the set of evens or the set of odds. Those are two ways you could do it. You could extend the ontology to one world, say Y, or to another world, say Z. And then it's a pretty natural requirement to say that whichever choice you make, you could always generate the objects that you chose not to generate at a later stage. And in that way, bring the two worlds back together and find a common extension of both. Right? So even if you had the license then to generate certain objects, and even if you chose not to exercise that license right away, so you chose to generate the set of evens but not the set of odds, you could always later on exercise that license. That doesn't go away. So then you get directedness as a property on these stages or worlds. And now we're ready to read off a modal logic that we're going to use to describe this process. So because we have reflexivity and transitivity, we at least get S4. But because of the directedness property, you also get the G action, which I put down here. So if something's possibly necessary, then necessarily it's possible. And that captures then directedness in the same way that, say, the forward action captures transitivity. So we add that in. And there's also context working formula, but we didn't dwell on that. So then we have a modal logic that we're going to use to represent this process. Now, when you're quantifying in the ordinary way, you will of course just quantify over what's available at a particular stage or a particular world. But there's a way of imitating generality that extends across all stages, namely by using certain modal operator quantifier hybrids. So you could say necessarily for all, or possibly there is. And that will then have the effect of talking about generate as much as you wish. And then it's still going to be the case that for all. Right? So it looks like necessarily for all will work like a kind of universal quantifier that extends across all the stages. And likewise for the diamond exists. And my next target is then to say a little bit about why these quantifier, these modal operator quantifier hybrids, I'm going to call them modalized quantifiers. And I'll say a little bit about why that name is apt, so why they actually behave like quantifiers in a certain sense, like devices of generalization. So tiny bit of terminology is needed. So phi diamond, let that be the result of replacing every ordinary quantifier in phi by the corresponding modalized quantifier. Right? So you replace for all with necessarily for all, and likewise with the special case. And then you have a theorem which makes good on this claim I just made, that these modalized quantifiers, as I'm calling them, they behave like quantifiers. So here's a theorem now. Look at a relation of deducibility. Could be classical first-order logic, could be plural logic, as suggested by some of the earlier stuff I did, second-order logic. Represent that by means of turnstile. Then let turnstile diamond be the result of adding our modal logic, and then adding actions to the effect that every atomic predicate is what I call rigid here, so it holds stably. If it holds, it will keep holding. If it doesn't hold, it will keep not holding. So in other words, atomic predicates, when they give a verdict, they stick with that verdict as you generate more objects. So if something is an element of a set, it will remain an element of that set. If something is not, it will remain not an element. We take out high-order convention actions for separate regions.
That's 4.2.
The modal logic from the previous slide. The modal logic from the previous slide.
Oh, okay.
Yeah. So S4 augmented with the G action. So the picture then is one of compatibility with ordinary theoretic claims or mathematical claims when stated in a language that doesn't use modal operators, because you have this mirroring figure. But you can now look at claims that aren't fully modalized, so where some of the quantifiers are not these modalized quantifiers. And then you could say things, make distinctions that you couldn't make otherwise. So the picture is that of looking at the very same subject matter, but under finer resolution, so to speak. So you stick with fully modalized formulas of the form by diamond, then everything is going to look as it did before, but you can now make these extra distinctions that you couldn't make. Right, so that's the background, and here's the payoff then for modal set theory. So this is a modal explication of the iterative conception, drawing, as I said, quite heavily on the last chapter on Charles's 83 book, but with some important differences. So you can, in a sense, then factorize a good deal of ordinary set theory in a very natural, very appealing way. So there's plural logic. We talk about many things at the same time. Kind of like Kantorian multiplicities. So very seriously, the Kantorian idea of the set being many made into one. So you have your plural logic, then you have axioms concerning the modality, which is representing then this dynamic process of generating objects. So S4.2, there'll be some axioms, I'm not going into details here, to the effect that you always generate as much as you can. Remember I talked about what you do if you have a choice what you generate. So a nice way to go here is just to say that, look, don't wait. Just generate everything you're entitled to generate right away. And then a kind of reflection principle is natural here. So this says something about not the shape of our modal space or logical space, but the extent of it. So a bit more specifically, one way of convincing yourself that something is possible is to see that that claim in question holds in the potential hierarchy that we observed in my statement. Now, what is it for a claim to hold in the potential hierarchy? Well, it's for the modalized equivalent of that claim to hold. So if you have the antecedent here, you know that the claim phi is possible, and then you want a possible world to witness that possibility. Pretty natural. Then you have extensionality principles for sets, and strong ones that extend across worlds. So basically the picture is derived in the area here. If at one world a set has a certain number of elements, certain plurality of elements, and if at another world the set has some plurality of elements, and these two pluralities are the very same plurality, then so are the sets, and both So you take ordinary extensionality, but in a transworld form. But the idea is the same as in ordinary extensionality. And then finally, this idea that Charles pointed to in one of my opening slides. Actually, an idea going back to KANT, as I said, sets being many things thrown into one. Right? And then you get all of our set theory. And in fact, if you strengthen the reflection principle a little bit, you get all the way up to ZF set theory. And choice can be added, nothing new is gained here. So I think this is an appealing way of, as I said, factorizing the actions of ZF set theory into natural groups, where you kind of see what's going on. And you take that generative idea very, very seriously. All right. So I've been putting off then the threat, which I mentioned, that all of these projects, so Charles's 2 projects, and then the Sojili project, that threat coming from global collapse. Now remember what the collapsing argument used. It used necessary existence of pure mathematical objects and the Browerian action. So the options are to deny necessary existence. If you think about it, this is what Aristotle does. Since mathematical objects, numbers say, they have to be instantiated. So for the number trillion to exist, there's got to be a trillion objects. So in worlds where you don't have a trillion objects, then that number wouldn't exist. Another possibility would be to deny the Browerian action for metaphysical modality. I think this is actually not out of the question, although that's a separate topic, and I won't say anything about it either. Instead, I will focus on the response that very clearly is favored by Charles, and which I think is the better way to get on myself. And that is to basically concede the collapsing argument as concerns metaphysical modality. But say that for the purposes that we have been looking at, we're talking about a certain mathematical modality to be distinguished from metaphysical modality. So I'm going to write that mathematical modality by black boxes and arrows. And that'll be all. So this response then prompts some pretty obvious questions. So what is this mathematical modality? That's the how are we to understand that? And how does it interact with other modalities? And here's an outline of what I'll go on to do. So there are 2 main families of answers to the first question. You could look at what Kit Fine very nicely calls circumstantial modalities. So modalities having to do with how the circumstances are. So natural modality, metaphysical modality would be examples of that. Or we could look at interpretational modalities, having to do not with the circumstances, but how the language is interpreted. So I think the paradigm example of that would be Jaworski's on. So in a sense, logical consequences has to do with necessary truth preservation. So necessarily when the premises are true, then so is the conclusion. But as you all know, Jaworski cashes out that idea of necessity there by talking about interpretations of the language. So the claim comes out as for any interpretation of the language, if the premises are true on that interpretation, then so is the conclusion. Right? So that's a good example of an interpretation modality. So we'll look at both of these families of answers. And then there will be 2 models for the interaction problem, or the interaction question. There is the galaxy model and the 2-dimensional model. The names are suggestive, but I'll explain them shortly. And the claims then will be that, in what follows, that early on in Charles's work, it's at least very strongly suggested that the mathematical modality is interpretational. Whereas in more recent work, it's very strongly suggested that the modality is circumstantial. And that the earlier way of understanding the modality is actually empirical. So that will be the main focus. So let me start with the earlier material on how the modality is to be understood. This is probably the easier idea to grasp. So here's a key passage. Among non-epistemic modalities, four should be distinguished roughly in order of stringency or necessity. So first, there's physical and natural, having to do with the natural laws and other more distinctively metaphysical constraints. Then there's metaphysical modality, actual finding working rules and so on, having to do with the metaphysical constraints. Then, even more stringent is mathematical modality, and then seemingly more stringent yet is logical modality. Although logical modality is pretty quickly dismissed, it's either an awkward notion generally, or not in the end very different from mathematical modality. What about mathematical modality then, according to Charles? Well, this necessity of mathematics should have the same formal character, he says, as the content of mathematical statements themselves. So it should be formal in a certain sense. That's somewhat helpful. But I think quite helpful, actually, is an analogy that's suggested by the previous longer passage that I quoted. So the idea you get here is that you could look at the relation between natural modality and metaphysical. And mathematical modality is just to take one step further in that sequence, in a certain sense. So what I have in mind here is that when we look at questions of what's possible with respect to the natural modality, then constraints would involve the laws of nature and metaphysical constraints. Then when you go to metaphysical possibility, you lift the requirement that the laws of nature be respected. That's taken right. Then when you go to mathematical modality, the picture that's suggested here is that now you lift even the metaphysical, the distinctively metaphysical constraints, keeping only the constraints are more mathematical in nature. So this suggests pretty strongly that the modality is now circumstantial, like the natural and the metaphysical modality. Although there's a problem or complication involving the possible non-existence of pure mathematical objects. And the problem is basically the following. So look at some pure mathematical objects that exist according to standard mathematics. So sets of uncountable rank, for instance. Then there are mathematical axioms saying that such sets exist. These axioms presumably count as being among the mathematical constraints in question. So then it looks like the existence of these sets will have to be mathematically necessary. So Charles is aware of this and discusses this in this passage. So it's not evident that mathematical modality is a unitary notion. I attribute it to a particular notion of mathematical possibility that allows it to be mathematically possible that there should be no sets of uncountable rank. So it's mathematically possible that you should just have the hereditarily countable sets. And that notion of possibility that it makes that, Charles considers then the natural notion for many purposes. Okay, we'll return to this if there's time at the very end. And rather than move on to the question about interaction with other modalities. And this is where the model that I call the galaxy model comes up. So the remarks about increasing strictness or stringency of the modalities very clearly involve a commitment to these two principles. So whatever's mathematically necessary is metaphysically necessary, and whatever's metaphysically necessary is naturally necessary. But let's state that then in terms of possible worlds. Not because we take that with ontological seriousness, but because it's a very vivid way of making some points. So in terms of possible worlds, this means that the accessibility relations will have to be nested in this way. So the accessibility relation corresponding to the least stringent notion of necessity, that will have to be contained in the metaphysical accessibility relation, which is in turn contained in the mathematical accessibility relation. So then we know a little bit at least on this picture about how the modalities will relate to one another. But here's the galaxy idea. So the possible worlds that are metaphysically accessible from some given world, think of those as a galaxy. So here you have a galaxy of worlds which on the standard S5 picture would all be accessible from one another. And then we think that mathematical fact and mathematical existence is then fixed as a matter of metaphysical necessity. Right? So no variation with respect to pure mathematical objects within that galaxy. So when you assert then some of these claims that we have been looking at, that consider all the actual ordinals, possibly they form set, then to find a witness to that possibility claim, you will have to leave the galaxy. Right? You have to leave the metaphysical galaxy and then go to some mathematically accessible possibility, which is not metaphysically accessible. But then you could look at a claim like 8 on the handout. So looking at all these objects, we assert that it's mathematically possible for them to form a set. And if they do, then that set will exist of metaphysical necessity. Okay? So this will require then that when you leave your home galaxy to find a mathematically possible world that has that enormous set, then there will be a little galaxy around that one too of metaphysical possibilities. And inside that galaxy, all the mathematical facts will be fixed. Okay, so that's a picture that one gets from the more recent work of Charles Parsons. So the modality used for mathematical purposes being circumstantial, and it being simply a stricter kind of necessity than metaphysical and natural. Let's now look at the early paper I've been quoting from before on the iterative conception of sets. And we recall then the metaphysical claims that we have been looking at to the effect that the multiplicity of objects that exist together can, but need not, constitute a set. The existence of the set implies that of its elements. So all claims that seem very metaphysical in character, and indeed Charles characterizes them as such. This is a more ontological view of sets. And then, right after having made these claims, in fact, in the passage I quoted at one of my opening slides, we found the following. So the same idea as in the claims just alluded to would be expressed in semantic terms by the supposition that we can use quantifiers and predicates in such a way that the range of the quantifiers and the objects satisfying any one of the predicates can constitute single objects. But these objects are not already captured by our discourse. So the same idea as in the metaphysical claims can be expressed in a semantic way by talking about how quantifiers and predicates can shift in their interpretation so as to get to quantify over more sets than we did before, and in that way say that there are or could be these problematic sets. So this very strongly suggests an interpretational understanding of the mathematical modality. And it also then prompts the question of how can that be? So here you have admittedly metaphysical claims that are given a very semantic laws. So what's the bridge here between the metaphysical claims and the semantic laws? I'll come back to a little bit of that. Let me now turn to the interaction problem as it looks on this conception of mathematical modality. So if the mathematical modality is interpretational, then we have two independent, or at least relatively independent, parameters or dimensions to operate with. So you could modify the circumstances. Now, the non-linguistic, non-semantic world is. Or you could change the interpretation of your language. And with that, then also affect changes to the mathematical ontology. So you get to quantify over more sets than we did before. And these are two relatively independent dimensions. So each dimension can then be held fixed while varying the other. So if I had a blackboard or whiteboard, I would have drawn a nice two-dimensional diagram here, but let me draw it in the air instead. So along the x-axis, you will have the circumstances. So there might have been different people in this room, all kinds of ways in which the circumstances might be different. Along the y-axis, you will have different interpretations of the language. And you could keep the interpretation of the language fixed as you shift how the circumstances are. Or you could do the opposite, so you could keep the circumstances fixed and then shift the interpretation of the language. So you get these two dimensions to play with. And then when you move horizontally, well, that's what I talked about. So let me just observe these two claims. So for a claim 5 that's purely mathematical, it's only concerned with mathematical stuff, then that will hold on metaphysical necessity. Since when you shift the circumstances, that's not going to be affected by any of the shifts. That's only concerned with what mathematical objects are. And then you could do the other kind of shift. You could hold the circumstances fixed and look at a claim that's entirely non-mathematical. So a statement about which people are in the room. Then when you shift the interpretation, then you're not going to change the truth value of that claim. So you will have that any non-mathematical claim that holds on interpretational necessity. So the picture is that by generating more sets, more intuitively put, when you generate more sets, you're not going to change which people are in the room and that sort of stuff. So you can generate sets, but you can't generate new people in the room. Or remove. Right, so that's a two-dimensional model. The question that naturally arises then is that of how the two-dimensional model relates to the galaxy model that I talked about already on. So the galaxy model permits a kind of horizontal move remember horizontal was to keep the interpretation fixed and in that way not change any of the mathematical factors. So there is a kind of horizontal move of not changing the mathematical facts, namely stay within the galaxy. The galaxy is defined as what's metaphysically accessible, and the mathematical facts are metaphysically necessary. The key thing to note here is that the galaxy model has nothing that corresponds to the vertical numbers, or keeping the circumstances fixed, and then changing the interpretation of the language, or changing the mathematical ontology. You see the difference between the two models also quite clearly when you look at the accessibility relations. So as we saw, the galaxy model, then metaphysical accessibility was properly contained in mathematical accessibility. But on the, at least on the pure two-dimensional model, then the two accessibility relations will overlap only in the identity relation. So if a world has both mathematical and metaphysical access to some other world, then the two worlds are one and the same world. So how do then the two models relate? Well, the first pointer suggests that the two-dimensional model is a galaxy model plus more structure. So you have your horizontal moves, but you'd like to introduce also vertical moves, and they're not yet available. And here's a way of seeing that that is indeed what's going on. Because implicit in the two-dimensional model is a third notion of necessity, where the previous two had to do with going on the x-axis or going on the y-axis. But there's of course also the notion of looking at the entire plane, speaking a bit metaphorically. So you could do that. You could call that box tilde, and then each of the mathematical and metaphysical modalities that you have on the two-dimensional models will be related to that third notion as on the galaxy. And so this is simply a way of stating that the two-dimensional model is a special case of the galaxy model, where you introduce even more structure, namely the ability to make not merely horizontal moves, but also vertical moves. Okay. Now why am I spending such a lot of time on the two different models? Well, my main reason is to be able to argue now that the galaxy model is actually inadequate for many of the purposes that we're interested in. So we're going to have to go to the two-dimensional model, and that sits better with the interpretation of understanding of the galaxy. So why am I claiming that the galaxy model is inadequate? Well, look at the claim, or one of the claims that we want to make. So for any object, xx, it's mathematically possible that there will be a set of just these objects. Okay? Now, what if that possibility was available only if the empirical facts were to change in a very annoying way? So you could generate a set of xx, but you could do so only if one of us had to leave the room, or as on the slide here, only on the condition that Socrates should exist, for instance. Right? So then you would have the claim about mathematical possibility that you made, but in a very annoying deviant way that interacts in a bad way with the non-mathematical stuff. Right? So if you have that situation, that the set in question could exist only on the assumption that Socrates should exist. It's a silly example, but it works. Then you'd have a situation where the set in question would be ontologically dependent, not just on its elements, which is a claim that Charles wanted to make, but also on Socrates in a proposed way. So what we need here is the ability to make what I've been calling purely vertical loops. So keep the non-mathematical circumstances fixed, and then generate more sets and other mathematical objects. We need the purely vertical loops. And that means going to the two-dimensional model. There's an analogous argument from the set theory of Oystein Linnebo. So how long do we push on? So 15 minutes, not bad. 5 more minutes. Okay, so you could respond to that argument I just gave about the need for what I've been calling vertical loops, so keeping the circumstances, non-mathematical circumstances fixed, and changing mathematical facts. You could try to respond to that by saying that, look, could you just add certain kinds of independence actions to rule out the annoying situation that you get your set that you claim to be mathematically possible, only on the condition that Socrates should exist. So couldn't we say something like the following, that it's mathematically necessary that given any object, and given any non-mathematical frame phi, you should be able to get the set that you're after while holding on to phi. Nice independence principle, that would go some other way. Now, it's not going to be strong enough since you want to be able to hold on to all the non-mathematical functions. So perhaps you could strengthen the independence principle in the way I put out here. If you are willing to, I'm not saying you should, but if you're willing to accept quantification into sentence position, then you could say that it's possible that there's a possibility where the second question exists, and any non-mathematical fact at that possibility corresponds to how things in fact are. So that's the down arrow undoes the effect of the innermost rule operator. The details don't matter, but couldn't you just introduce stronger and stronger independence principles, saying that you could get your mathematical possibilities that you're after, holding on to or keeping the non-mathematical stuff fixed? Well, perhaps you could, but look at what would happen. If you go that way and insist on full independence in that way, then you will be able to retrieve the kind of vertical move that's on the debate. Right? Then you could say that I want to consider necessity in the sense of what's necessary on the assumption that all the non-mathematical stuff should remain fixed. So if you introduce independence principles to deal with the concerns, what you're doing is basically to introduce exactly the resources you need to get the two-dimensional model. So this is just getting the two-dimensional model by factor. So we're stuck, I claim, with a need for this two-dimensional model. So, taking stock. So I've argued that the galaxy model is insufficient and that we need to go all the way to the two-dimensional model. And that the interpretational understanding of the mathematical necessity operator, that gives you, it very, very naturally suggests the two-dimensional model, while the circumstantial understanding of it does not. In fact, if anything, it suggests the opposite if you have the picture of getting from metaphysical necessity to mathematical necessity by relaxing some of the constraints that you impose on what's required for a situation to come to possible. Then the analysis will be nested and not factorizable as on the two-dimensional model. Are there any direct arguments for the circumstantial understanding? I think I'll skip that actually. We could come back to that if anyone wants to talk about it. Just some last observations before I end that. Remember the puzzle we had about Charles making some very metaphysical sounding claims about sex, and then saying that the very same idea, or same idea, can be cashed out in this semantic way. So to have a bridge between the metaphysics there and the semantic claim, we need a substantive account of the interpretations that are to shift, or be shifted by this mathematical necessity. And there's no easy way here. If you quantify over all interpretations, like Oslo in the definition of logical consequence, then of course all of the claims that you after will be regular forms. For instance, that epsilon might have meant loves instead of being a member of them. These claims will all be false. If the quantification over interpretations is restricted to interpretations where they write properties, so say you're interested in the necessity of membership, set membership, if you simply build in that, oh, I'm just interested in interpretations that would respect that, then that claim that sex have your members by necessity, that will be trivial. So that's also another option. So you will have to be much more forthcoming about what these interpretations are and how they can be of metaphysical significance in order for this to work. And I've got some ideas about that in recent work of mine, tying some of that to abstraction. So you could look at it in terms of sets, and where you could get sets by abstracting on pluralities under the equivalence relation of co-extensionality. So you could see that as a way of extending the language and giving content to talk about more sets. But that is to suggest that there's a real hard question there, and some extremely sketchy remarks about how one might go about responding to those questions. So that's it.
Yes, thank you, and now we have a good deal of time for discussion. Charles?
Well, this is so directly taken on mine. I really owe some comment. Charles, you? Oh, the microphone.
Oystein did fine without the microphone, but I guess it doesn't necessarily follow that others will. The first thing I want to say is that the particular theory that is, I guess, on the handout under the heading, in the second page under the heading, a modal explication of the iterative conception, has a probably not coincidental resemblance to the theories that I call theories of potential sets in that last essay in mathematics and philosophy.
That's the one I'm citing at the bottom of the slide.
And it's Oystein's version is a very great improvement on it. It's especially much simpler and more perspicuous. I guess the second main comment I'd want to make, but that I would suggest where I'd go further with it, and I'm not sure about it, and that is that he, in the main part of his talk, has developed complexities and difficulties about how you understand the notion of mathematical modality as it was deployed in the context that he's most interested in, namely where the possibilities in question are those of generating more objects. I think I had other things in mind as well in the remarks about mathematical modality in mathematical thought objects. And it's possible, entirely possible, that there was confusion in my mind between what you call the circumstantial and the interpretational reading of the modality. But all I can really say is that you uncovered a complicated problem and have done something about it, and I hope it goes further.
Yeah, just to comment briefly on that, so concerning the use of modality in, or the discussion of mathematical modality in the mathematical thought work, of course the context is a different one here. In that that's part of a discussion of structuralism and modal structuralism specifically, where you're discussing the question of what the right modality should be for modal structuralism. So the context is different, but not entirely different though. And I think you see that in part from slide number 12, where there is a discussion of Tottenham. So what about a mathematically possible world where you only have hereditarily countable sets, for instance? So it's not clear that one needs to worry a great deal about that possibility for the purposes of modal structuralism. And the discussion of Tottenham does suggest that some of the older agenda remains in place. Yeah.
Commented on a remark of someone himself commenting on that Putnam article, who said that, well, what's possible is what's compatible with CF or something like that. And it seems like not permanent, but not what you should be doing mathematical possibility in this sort of discussion.
Yeah. You have asked the word. Did you ask the word? Stuart was that a question?
I have a question, but
Oh, you do have a question?
yeah.
Who's gonna go first? Do you hear her?
Now
Well, somebody
somebody has to go?
has
Go ahead,
to-
Stuart.
All right.
Ask the question.
Well, I forgot it. Yeah, the one I want to ask you about this, as you know, we've talked about this, that the intuitionists too of all stripes sometimes talk about the natural numbers anyway, as in potential terms, in terms of potential infinity. Now, Kripke structures just don't get that. The Kripke structure intuitionistic logic don't capture that at all. I mean, all of the nodes after the first are going to be something like non-standard models. So a system like yours would seem like it would be the right one to try to get what they're onto, except that I don't see how we're going to get anything like intuitionistic logic in there. Have you thought about that?
I think you know the answer to that, Stuart. Yes, I have. I have not made up my mind entirely about it though. But yeah. So when explicating the idea of potential infinity, you actually find it in Aristotle and the intuitionists. I think this framework is quite a nice way.
It looks like the right framework. It's just like it's not going to give the right results.
It's by the intuitionists' lights. It's not.
Yeah, well, that's what I meant. That is, you'll get something like potential infinity, but you're not going to get, like, for example, if it's S4.2, you're probably going to get, you're not going to get it. You'll get excluded middle, at least for negated formulas, and
you'll get for every phi not phi or not phi.
yeah, and probably even worse because you're probably not going to. At least with the natural numbers, you only have one thing to do at each stage, make one more number. So you're not going to even get any splitting. So you're going to get a linear frame,
Yeah, so
and that's really not going to. At least the way you're setting it up, that's really not going to give you the right logic.
So that's not going to give the right logic. What's
Yeah.
so much worse for for that.
Oh, that's okay. Okay, I mean, yeah, I was looking at a way to capture what they're up to rather than showing that they're getting it all wrong.
Now then I think
Right,
you'd
yeah.
have to, if you really want to capture what they're up to, and I think that's a good project. Although I think my project is a nice one too, of trying to separate that idea of potential infinity, be that at the very low level or the very high level, to separate that from the question of the logic. And this shows how that
all right, so then
we separated.
that would show that there's just something wrong with how they're thinking, because they think that you're actually forced to that logic because you're thinking of these things potential, or so they think.
So they think.
Right, and you'd be arguing against that rather than.
Well, I think to go that route, you need an argument that where I have classical as being too, that the right way to proceed is something like intuitionistic as whatever exactly that would be.
It's still
And
going to be.
that's the kind of material I
Yeah.
haven't yet looked into, but
Okay.
that would be the way to pursue that on.
Okay.
And of course, coupled with philosophical arguments why the logic of the whole logic here should be the intuitionistic one. I just haven't gotten that far.
Okay.
Yeah, so let me first begin with the question. I've always been agnostic on potential actual okay, bring it back. Is that okay? I've never been able to really get a grip on it with some kind of modality, so I kind of find principle tolerance on that. Let me say something in favor of potentialists and then maybe something in favor of the actualists. So we're interpreting mathematical modality as interpretation. Well, that's one of the options. And one of them is just make a suggestion. I'll consider this, but you might try using Kip-Fine's logic of essence. So with all of these, I think there are some problems with the but and the approach through essence might help. If you look at one of these worlds, they're downward closed, they're transitive. But you can move forward the accessibility relation and then add on the set. And one way of capturing that asymmetry is by using Kip-Fine's notion of essence. So he points out that if you look at metaphysical necessity, and you consider Socrates and the singleton set containing Socrates, then they hang together, right? If Socrates exists, then necessarily the singleton of Socrates exists, but there's an asymmetry. Namely, that if the singleton of Socrates is around, then Socrates is kicking around. It's part of the essence. You can't get it out.
I'm delighted you say that.
And then if Socrates is around.
This is what I had in mind, or at least to what you said so far. Is what I had in mind by saying that. This is actually not having a question.
Okay,
You
so
could get asymmetric ways of thinking about it, even when you're talking about metaphysical you exploit some of these ideas.
okay, so yeah, and Socrates is around. It's not part of the content of Socrates. So there's, it's essentially true of the singleton and Socrates. So that's a more fine-grained notion, and you might use that, and I think it has advantages over the interpretation of
Yeah.
Can I point out a problem with the interpretation?
Sure, but I'll make a remark maybe before we point out the problem. I like these binding ideas, and I think you can get quite a lot of the asymmetry when you're gesturing that. And that is what, as I said, what I had in mind, I was saying that the Barbarian action is actually not non-negotiable. However, the arguments that I gave towards the end of the talk in favor of the two-dimensional model, they were sound. So it could well be that perhaps you could develop this, but if so, then getting that two-dimensional structure would be a constraint on the project. And
I don't really understand that. I thought that
probably would be all right, actually. That would probably get the two-dimensional aspect on that way of proceeding. So, good.
So, a reason for thinking.
Go ahead.
I was going to point out a problem.
Point it
Oh,
out.
no, yeah,
You know,
Point that sucker out.
when we're doing set theory, we discover new large part lines, and we don't think that we've changed the interpretation of set theory any more than when Hughes discovered the Hughes number. We thought that we changed the interpretation of the number. Saying, yeah, that's a old-fashioned, well-founded set. That's what I'm talking about all along. And then there's also the categoricity argument. So you're in a world where you have V omega, and I have V omega, and we start tacking on subsets of V omega. As long as we both agree with Pfefferman's second-order arithmetic, then you can just use comprehension on either side to build a isomorphism. So in terms of interpretation, it seems that we're in the same boat, we're in the same world. But in terms of essence, it seems we can make the decision.
So on the point about our not being aware of shifting any interpretation, changing any interpretation when we discover logical interactions, part of the idea of the way I'm deploying this mirroring theorem is to address exactly that concern. So when I'm saying that these model operator quantifier hybrids behave like quantifiers, so that we in fact do in a very precise technical sense, that's to be able to address that kind of point. So you were saying that, look, this looks and feels like I'm just deploying ordinary quantifiers. And I'm saying that, no, really they have to be factorized in this way. But what the theorem shows is that at least my interpretation of the kind of universal generalization that Hamilton says, at least my interpretation of that is compatible with the data. Since all of your claims about what set theory is true, what follows from what, and so on, all of that can be respected. So it's compatible with the data. It's going beyond the data, and that needs to be well motivated. Unless it is, then of course one should go with the simpler interpretation, which is important to go this way. So this is part of the big package really, where the hope is that there will be enough advantages for proceeding in this way to show that going beyond the data in that way and interpret more universal quantifier and maybe more receptive in this way, that's actually a good way to proceed. So the case for that is broadly pragmatic, that have explanatory payoff that's sufficient to be processed.
I wasn't interpreting this saying in mathematical visionary.
No. So there was something I didn't understand. Could you go back to slide 9? It might just be that I don't understand, in which case you can clarify. But so there's 3 options for blocking the collapse, the modal collapse. The third one, which is the one you've been pursuing, is the one that involves having to have these considerations of interpretations and two-dimensional model and all
Well,
that.
or at the very least, a distinctively mathematical model.
A distinctively mathematical
It's
model.
up for grabs at this point how that is to be understood.
And then that has to be interpreted and so forth. But if B works, then you don't have to do that, right?
If B goes.
Then if B goes because the finding out.
That's right.
So that seems like a simpler way of blocking the modal collapse. And then you don't have to get into this other more complicated thing. But of course, since it is complicated, that makes it interesting. And there may be other motivations for wanting there to be a mathematical modality aside from the others. But it wouldn't necessarily be the modal collapse. For modal collapse, you have to.
That's right. So look at Charles's work, where he doesn't particularly discuss the collapsing problem, although I'm sure he was fully aware of it. But yet argues that the modality ought to be a distinctly mathematical. So there could be all kinds of reasons pushing in favor of 3 over and above the threat of collapse.
But then it would be constrained by the need for it to block the collapse.
No.
Okay.
So if you're willing to let go of the Valerian action, then you're you're in the clear as far as the collapsing object is concerned. But that's a pretty big step. And think about trying to make that argument that for these distinctively mathematical reasons, all new manifestations are wrong about the logic of metaphysical modality.
I like the sound of that.
And especially when spelled out in more detail in the way that Peter was mentioning. So there's a way of presenting that, at least in my version, that's very, very intuitive. Let me tell you that one. So the situation is possible metaphysically if all essential properties of all objects in that situation are respected. Right? So it's an essential property of the singleton of Socrates that Socrates should be around. So if that set is to be present in the situation, then the single element better be present too. Maybe it's essential to you to be human, so if you're going to be around, you better be human. That's fine. And then it may well be essential to Omega, to accept that it should exist. So if it's around, then it will insist on remaining around. So anything that should count as accessible from the point of view of that situation should be the situation in which all essential properties of all objects in the previous situation should be respected. So once you get Omega in there, you can never get rid of it. But this is a little bit like what Kant says on the ontological argument, to connect up with Kant here. If Omega is not around, right, then it raise this hand and say that, look, I exist necessarily, and shouldn't I be around? But if Omega is not around, then it's not going to be able to make that complaint. Right? So this situation is possible then only if, or if and only if all essential properties of all objects in that situation are respected. But once excluded, objects excluded from that situation, their essential properties really exist. So you could spell that in that way, and that's starting to be a pretty nice way of actually pursuing option two. Although with the constraints I mentioned in my response to Peter, that the argument for that kind of two-dimensional structure, so the ability to generate more mathematical objects, leaving the non-mathematicals are fixed, that argument. Yeah.
What was the comment that you made? I seem to go by pretty quickly about ZF.
Oh, I don't know.
That was on slide 8. We obtained Z. We obtained Z from.
Oh, I see. Right. Okay. Good. Yeah. So some other sentence. So what's missing here is replacement.
Right. And
to get replacement, there are many ways to go. Charles's way of proceeding is actually quite a nice one. So let me mention that. That's to this is where Blackboard would have been wonderful, but I'll have to do it in here. This is to say that if you're in a situation where necessarily
there's a whiteboard.
The whiteboard.
I'll describe it. It's not that super complicated. If you were in a situation where necessarily for any x, possibly that x bears 5 to some y. So it's like a situation of potential infinity. So necessarily for any object, possibly it bears 5 to some other object. If so, then it should be possible to complete that potential infinity. So in other words, then it should be possible for it to be the case that for any x there in fact is a y, such that y is. Right? So That's a way to get that last step up to replacement by adding that principle. Another way to do it would be to tweak the reflection principle in a way that makes it ever so slightly less well motivated, but stronger, such that you get replacement. So that's the kind of moves I have in mind.
So when you call this a modal explication of the iterative conception, we're just to understand that as Z, as actually defined by Z.
Oh, sorry. No, that's really just a feature of how I set it up. So that's primarily a result of pedagogical consideration. So I wanted the really simple, attractive, easily explained reflection principle. Since it's just it's so simple and so attractive, I think you see what I had in mind there. Had I had significantly more time, I would have done the full one and then column replacement. Well, this is super attractive in that it looks very, very close to the T principle, that whatever holds is possible, except that there is a special domain in which one may hold now, or situation in which one the possibility may be witnessed, namely the whole potential hierarchy that you're considering. So if phi holds in the potential hierarchy, so for instance, phi could be the claim that phi diamond could be the claim that necessarily every set possibly has a singleton. Right? Then the claim that every set has a singleton, that's a witness to the potential hierarchy you're describing. Well, if it's witness there's a kind of model in which it holds. Right? And if there's a model even of this kind of sort in which it holds, then surely it's possible. So, that's the attraction of this principle, which is why I put that on there rather than the full one, and which was to put C there instead of C.
Charles has another nice paper. What is the iterative conceptual set?
That's the one
That's 1977.
Yeah, right. And then there are all these variations of conceptions of what iterative, what the iterative conception actually is.
Yeah, that's right. It's probably a somewhat loose notion, so I think it's probably fruitless to argue about what exactly is modern iterative conception. So I'm perfectly happy to have a full reflection principle here. At least I don't have a firm view on that.
Yeah, I'm a bit dim on this. In fact, I may be a bit dim now anyway, some of it. But Jeffrey Hellman had some kind of modal reflection principles, I think, from which he got the small arch cardinal.
I've looked at that. So, there's a lot to be said there. So, Jeffrey is interested in this in the context of modal structuralism, but the structuralism versus not aspect is really irrelevant to what we're discussing. So, he's looking at basically pluralities and basically it's a reflection idea.
Oh, he used the polarity.
What, sorry?
He used the polarity.
Well, he uses second order logic on a strongly extensional interpretation, which comes to the same thing. So his classes or whatever he calls have the same kind of modal profile across worlds that might provide this. So it doesn't really matter what they are. And your question then forces me to clarify something important about this principle. So it's very important that the fiber should be first order. Because if it's not, consider having phi be the claim that whenever there are some things, there is a set of those things. Right? The mobilization of that holds. Right? So necessarily whenever there are some things, possibly there's a set of those things. But it's impossible to complete the potential infinity of the whole hierarchy Right, and I've got a story about why that's perfectly fine, why that shouldn't be worrisome, we should just embrace that, and let Phi be the first order. Jeffrey does not want to do that. It's more ambitious. So Jeffrey wants Phi to be any claim in his language, and then impose other restrictions to avoid paradox. And he's fiddling around with that, and the restrictions are, in my opinion, not very well motivated. It's exploded a couple of times. So it's not an overly reassuring, but on one version he's got, but paying a price then in terms of security and motivation.
Oh, yeah, a very brief question. On the last slide, you mentioned predicative abstraction.
No.
And what is that?
Oh, how much more time you'll give me? So the idea, let me describe the simplest case of what I have in mind. What Frank says about directions. So you could consider two lines, and then you could talk about the directions of those two lines. Then any identity claim that concerning these two directions can be translated back into the base language, not saying anything about directions. And the same goes for other predications, like this direction is orthogonal to that direction. That can be translated back into the orthogonality claim concerning lines by means of which these directions are presented or given. So it's moves of that sort where you introduce virtual classes with the given where you allow yourself to talk about certain new objects while ensuring that all that talk about the new objects can be translated fully back into the reason. By iterating moves of that sort. That's easy.
Yes, thank you very much for the great discussion. And now we have just finished on time, and maybe have some information on
Let's go eat.